Two rules for solving equations. Hello, I'm Mike Royer. The intended audience for this presentation includes people who are just learning about working equations, people who are working equations again, maybe after being out of school for a while, and people who find they need to refresh a little bit and use equations at work. So you might be in the back to school zone, or you might be in the work zone, or perhaps both. First, here's some equation basics. What is an equation? An equation is a math statement or sentence that says that two expressions are equal. In English conversation, we might say, this equals that, or this thing equals that thing. Here's some equation examples. 3 plus 5 equals 4 times 2. 10 minus 1 equals 3 squared. 5 times 3 plus 4 equals 35. These are all math sentences using numbers. And also, it does not matter at this point. A little later on it'll be different, but at this point it doesn't matter if the statements are true. We're just saying they equal each other. These are equation examples. Now, equations also use letters in addition to numbers, and we call those letters variables. Maybe something like x or y or a or b. Now, variable, simply something we don't know. That's all it is. Sometimes people look at the x or the y and they, oh, what's that? That's confusing. Okay. Well, it's just something we don't know. That's all it is. It could be what you ate for dinner. It could be how much your electric bill will be this month. It could be whether you will do something or not, or anything we don't know. So when you see x's and y's or a's and b's along with some numbers in an equation, stay calm. We're going to use equations to find out what those letters are. So just a quick review. An equation is a statement or a sentence that says two things are equal. We use letters called variables to stand for the things we don't know. This is one time in your academic career when really it's okay to not know something. We don't know what these things are. And right now, that's fine. Okay, for example, let's put the letters and numbers together and see what kind of statements they look like. 4 plus x equals 11. Or another example is 3x equals 24. Or maybe x minus 5 equals minus 2. Now we could also say 4 plus something we don't know yet equals 11. Or we could say 3 times something we don't know yet equals 24. Or we could say something we don't know yet, minus 5 equals minus 2. So these are equation examples. Now, finding out what we don't know yet, like x or y or a or b. Well, examples like 4 plus x equals 11, those are pretty easy to figure out. What plus 4 equals 11? Or 11 minus what equals 4? You can probably do all that in your head. However, there are going to be more complex problems later on, not as complex as what this guy is working on here, but some more complex ones. So you will need a method for solving some of those equations. Now that's where the two rules for solving equations come into the picture. Let's take a look. Rule 1 for solving equations. We generally solve equations by isolating the variable, get it by itself, on one side of the equation. We do that by performing inverse or opposite math operations. In the example, 4 plus x equals 11, we want to get the x on the left by itself so we can find out what x is. So we need to do something to cancel out the 4. We can cancel out the 4 by using inverse or opposite operations. In this example, the left side of the equation reads 4 plus x. Plus means addition. So, we will use the opposite type of math, or subtraction, to cancel out the 4. We will subtract 4 from the left side. 4 minus 4 plus x equals 11. Now, 4 minus 4 equals 0. So the equation becomes x equals 11. However, we're not done yet. Let's take a look at Rule 2. Rule 2 says Whatever you do to one side of the equation, you must also do to the other side. We just subtracted 4 from the left side of the equation. So now we need to subtract 4 from the right side of the equation also. Right now here's our equation, x equals 11. Now we're going to subtract 4 from the right. X equals 11 minus 4. 11 minus 4 is 7, so now we have x equals 7. Now we know what we did not know yet a minute ago, that x is the same thing as 7. That's what x is equal to in this equation. By the way, here we can check if the equation is true. Does 4 plus 7 equal 11? Yes, it does. So we have an accurate answer. We know we have done the problem correctly. So let's look at another equation. In this case, we'll get a little practice here with x minus 23 equals 45. To get x by itself on the left, add 23, which is the opposite of subtract 23. So our equation becomes x minus 23 plus 23 equals 45. Minus 23 plus 23 equals 0. So our equation becomes x equals 45. We've got the x by itself over on the left-hand side, or whatever the letter might be. Now we must also add 23 to the right side of the equation, since that is what we did on the left side of the equation. So let's do that now. X equals 45 plus 23. We're adding 23 to the right side. 45 plus 23 equals 68. So x equals 68. Check it. Does it? Does 68 minus 23 equal 45? That was our when we put our numbers in for the letters of our equation. You can check it out. While you're doing that, I want to remind you a couple things here. You may be able to do these problems, especially when we first start out with equations. You may be able to do most of these in your head. But especially later on when you have some more complex issues, that may or may not continue to be true. Now, I've had students that were incredible, that could do all kinds of math in their heads and get accurate answers. For me, I generally have to write things down, okay? Either way is fine as long as you're getting accurate answers. But I find that I need to write it down, and I need to write it down like we've gone through these problems step by step. That's what helps me. You may find that helps you also, maybe not. I just wanted to mention it here at this point. So 68 minus 23 does equal 45, so we know that in this case x does equal 68. Okay, to summarize, remember Rule 1. Isolate your variable, the letter, by using inverse or opposite operations. If it's adding, subtract. If it's multiplying, divide. Rule 2. Whatever you do to one side of the equation must be done to the other side of the equation also. Again, you're going to work with more complex equations, but these two basic rules will always help get you started correctly. My experience in class has been when students start working the more complex problems, they usually do the more complex part fine, but they may forget to use inverse or opposite operations, or they may forget that what they do to one side of the equation, they must do to the other side. So that's why I say these two basic rules, you're going to go back to them again and again, and just remember those when you start out, and you'll be fine. For more on starting to solve equations, see pages 348, 349 of the 2015 Kaplan GED book, or look for equations in the table of contents of the Kaplan GED book you are using. If you're in a adult basic education or ABE class, take the book that you're using in class and check either the table of contents in the front or check in the index in the back for equations. And if you need assistance, you can also visit the Online Academic Support Center at www.daytonastate.edu/ASC.